Alright guys, we're looking at chapter 9. Some would say chapter 9 is a very significant chapter because of the significance testing. A lot of this is going to be verbal once more, so please have the sound on. Listen to this at one speed if you're studying up for the AP test coming up in 10 days. Please use all your resources, Khan, Mrs. Daniel's site, StatsMag, there's so many things you can find for AP stats. So again, pause it, try the problem, and then I'll go over it. So Mike is an avid golfer, ... What's the parameter of interest in this setting? So what are we trying to find out? Well, since Mike wants to be more consistent, you care about the standard deviation. The smaller the standard deviation, the more consistent you are. Now let's state the appropriate hypothesis for this situation. When we know our null hypothesis, what we assume to be true is that the standard deviation equals 15. Alright, so he thinks he's going to be more consistent with this new 7-iron. So more consistent would mean a smaller standard deviation. Okay? Alright. It's moving right along. Alright, so then he takes some shots with his new 7-iron, and he got the standard deviation in his sample was 10.9. He used the significance test, and he got a p-value of 0.02. What does that 0.02 mean in context? That 0.002 means there's a 0.2% chance of obtaining a value of the standard deviation being 10.9 due to random chance. Remember, the p-value is the probability of getting the data you did by chance if the null hypothesis is true. So again, if you were to word this, it'd be we have a 0.2% chance of obtaining a value of this standard deviation being 10.9 due to random chance alone. Does this provide convincing evidence against the null hypothesis that his standard deviation was 15 or 14? What was it? 15. Well, yeah, because the p-value is very small. There is convincing evidence that the true standard deviation of a 7-iron is less than 15. So you would reject the null. There is significant evidence. Remember, if you reject, you have convincing evidence of whatever your alternative is. Now let's go to E and interpret in context. So we can say that Mike is more consistent with the new 7-iron. That's it. And we have significant because we rejected the null. There's only a 0.2% chance of him getting those results just by chance alone. Pow, 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 erase. Alright, let's do some more stuff. Alright, so we're doing a Gallup poll like a horse. Alright, so pause it, read it, try it, love it, do it, learn it, bop it. Alright, so what's our null hypothesis? We believe, or right now is assumed, that the proportion is 0.72. But we believe, or we want to test our alternative. It doesn't say less than or greater than, that p is not equal to 0.72. She just doesn't think it, she thinks it might not be true in a large high school. So Yvonne samples 96 students and gets a p-value of 0.0291. Okay? Interpret in context. So what that means, again, this is a verbal answer. I'm going to try to do the best I can. If the proportion of students at Yvonne's school is 0.72, there is a 2.91% chance of finding a sample of 150 students with a value of p that is as far from 0.72 as the sample value in either direction. Okay, so that means there's a 3% chance of obtaining her data by chance. Does this provide evidence against the null hypothesis? Well, yeah, because 0.00 or 0.02 is less than 0.05. 5% threshold. So yes, because the outcome that she got is rare, we can reject the null hypothesis. And it looks like that the percentage in Yvonne's school is different than national. Okay. So that's 9-1. Oh, let's just talk about one more. Hemoglobin. Hemoglobins. Alright, what is pause it, read it. I've already done it all. So our mu we're looking for is the true hemo level. Wow, handwriting class. Our null hypothesis, or what we think is what's common, is that mu is 12. Our alternative hypothesis, what we think might be true, or what we want to test, is we want to see if it's less than 12, because that'd be important. So we looked at the children and we found that they were 11.3 grams per deciliter. Standard deviation was 1.6 and the p-value of 0.0016. Interpret the p-value in context. Alright, this tells me there is a 0.16% chance of finding a sample of 50 children with a mean lower or of 11.3 or lower. So what conclusion can we make? Well, if alpha, we can reject both. We can reject the null hypothesis if it's 0.05. We can reject the null hypothesis if it's 0.01 because we got 0.001 as our p. So we have convincing evidence that Jordanian children have a lower than average hemoglobin level. Alright guys, we're looking at 9.2. Nice thing about chapter 9 and chapter 8 is you can watch my other videos as well for these. So please do so if you want, or find other people's videos. There's other teachers who are better than me. Alright, so let's do some significance test of proportions, y'all. I'm going to do this the shorty cut method. Alright, we're looking at potatoes with blemishes, right? Y'all can read. That's too big. Alright. I'm not going to do phantom, I'm going to do state, plan, do, conclude. So state. Alright. What do we want to find? We want to find actual proportion of blemish potatoes, right? What's our null? What do they tell us is true? They say that the potato should be at 0.08. Right? Or that no more than 8% should be blemished. So as someone who's receiving potatoes, I want to test. Oops. Jeez. I want to eat some potatoes. I want to see if this is over 8%. I'm going to go to plan. Alright, I need to test my stuff. Is it a random sample? Yeah, it's a random sample. Is it normal? For proportions, that means n times p. And you have to check n times 1 minus p, right? And those do check out. Because you have 500, guys. 0.08 times 500 is bigger than 10. These have to be bigger than or equal to 10. Is that less than 10% of potatoes in the shipment? Yes. 500 is probably, there's probably more than 500 potatoes in a shipment. Do. Alright, we need to obtain our p-value and our test statistic, which I'm going to pause it now to put a break. I'm going to use my calculator. You'll see it's going to be a separate video. Alright guys, we're going to look at the potato problem. So we got to find our p-value and our test statistic. So I'm going to hit stat test. Now we are doing a proportion test, correct? So I'm going to do a 1 prop z test because I have one proportion. I'm not comparing two. All right, so my p sub 0 is my null. What's my null p? That's 0.08. My x, how many potatoes had blemishes? Well, that was 47 out of the 500, right? Now, what are we looking for? We believe that our null hypothesis is that that's greater than, our alternative is that it's greater than the null, right? Calculate. Boom! There's our stuff, guys. There's our p-value. I'm going to write this down. So p is 0.124. Our z was 1.15. Right? All right. I hope that helps. Back, you saw the calculator told us our p-value was 0.124 because our standard deviations away was 1.15. Then we can go right to conclude. What can I conclude based on that p-value? All right. So because, listen very carefully to me. Because our p-value was bigger than our alpha on this one. Oh, by the way, our alpha was 0.1, right? We fail to reject That means there's not sufficient evidence to conclude the shipment has more than 8% blemished potatoes. Okay, so that truckload's fine. We can use them to make our tater chips. All right. So we failed to reject because P was bigger than alpha. We do not have sufficient evidence that the proportion of blemished potatoes is greater than 0.08. Next one. Smoking in high school. Shouldn't smoke, guys. There's enough lung stuff going around, I do believe. All right. So, again, we're going to be doing a proportion test, y'all. Pause it, read it, do it, find your paper. There's nothing like working out this problem than having to work it out again for y'all. It's fine. I will persevere for you guys. All right, so state, Michigan, liquid. I don't know. Our alpha we're looking at is 0.05 because it doesn't tell us anything else to use, so it's 95% significant. Our P is our true proportion of smoker or of never smokes in Tavon's high school. Our null hypothesis. They say 50% of students have it, but Tavon thinks that his school is different. Does not hold up. All right. Check conditions. Check conditions. Is it random? Yes. Oh, this is the plan. Is it SRS? Yes. 0.5 times 150 is bigger than or equal to 10, so it's normal. Is it independent? 10% rule. Yes. In a large high school, guys, this might come as a surprise to you. There's probably more than 1,500 kids. Most Class A schools have 15 to 2,000, so, or 1,500 to 2,000. I mean, that's a little bit different than us, but let's do. All right, I'm going to fade off again and go to my calculator and come back with some statistics, okay? All right, let's do the smoking problem here on our calculators. I'm going to hit stat, go to test. Again, this is a one proportion z test because we're dealing with proportions and we have one of them. Our null for this one is 0.5. And out of it, we took our simple RAM sample. We got 90 of them. and we took a sample of 150. And now this time we're saying our alternative hypothesis does not equal our null hypothesis, right? And let's calculate. Boom! Z is 2.449, and our P is 0.0143. That easy, y'all. And I'm back. And I got what? My Z was 2.44. Uh-oh, I didn't write it well enough to read it. 9. And my P is 0.0143, right? All right, conclude. Listen carefully, y'all. I would write it. I honestly have a hard time writing with this software currently. I don't know what's going on. So our p-value is less than our alpha, right? P is less than alpha. So our p-value is very small. Because of that, this is conclusion. We have convincing evidence to conclude that the proportion of students at Taeyeon's school who say they have never smoked is different than the national result of 0.5. Okay, so we have significant evidence. We can't say greater than or less than because that's not what we were testing. All right, we're going to move on to the next one. I like to put breaks. 9-3 time, y'all. Hey kids, now we're going to be doing significant tests with mean. So these are going to be t-tests, not z-tests. Because with mean you have to use t because it's more accurate than using a z. Okay, so we're looking at DO, dissolved oxygen levels. Y'all can read. All right, it's time to do our state, plan, do, conclude. State, Michigan. It's still funny. Regardless if you're whatever. All right. I'm trying to find my notes actually. All right. So our state, we're looking alpha is 0.05. We're looking for our mean, our true mean of dissolved oxygen in stream, right? Our null hypothesis, it shouldn't be below, so it should be 5, not 0.5. 5 milligrams per liter. Our alternative, what we're trying to test is it less than 0.5, right? Not 0.5. Why do you keep on? We aren't doing proportions, Mr. Terwilliger. All right, let's do it, y'all. Plan. Is it a simple random sample? Yes. Is it normal? Well, it's less than 30, so we actually have to dot plot it or box plot it, and it is. Look at the data. It shows no outliers or skewedness. Is it independent? Is that less than 10% of all the samples you can take in the stream? Oh, yes, it is. You could take 1,000,000. There's so much water in there. Do. Fade out to the calculator. Ooh. And I'll come back. All right, this one we're looking at the milliliters per or milligrams per liter aquatic life. I'm going to hit stat, edit, and plug in my data. All right, I'm going to hit stat, test. Now this is a one sample, right? We took one sample, t-test. All right. All right, I guess I can just go t-test. Sorry, guys. Let's try it. So what's our null hypothesis? Our null hypothesis is we think that it's 5, right? We're using list 1, frequency 1, and we believe that our null hypothesis is what? It's too big, right? So we think that the real mu is less than our null hypothesis. Hit calculate. Boom. Got it. Data. Done. I got my t value. T is negative 0.943, and my p-value is 0.181, or 809. All right, our degrees of freedom was, look at this, well, 14 because it's n minus 1. All right, sorry that one wasn't great. And I'm back, I made it. We are okay. So I got T was negative 0.9426, and a p-value of 0.181, right? So now let's conclude. Again, this is going to be verbal, so please listen. Our p-value is bigger than our alpha. 0.181 is greater than 0.05. So we fail to reject our null. So the conclusion would be, we don't have enough evidence to conclude that the mean dissolved oxygen level in the stream is less than 5 milligrams per liter. All right. Last problem. I think it is. Yeah, it is. All right. Pineapple company. Who lives in a pineapple under the sea? Got my paper. All right. Here we go. State plan to conclude. This one's going to be a two-tailed test, which makes it a little bit more difficult. Again, please read it. Try it. State. What are we trying to find? Mu, which is the mean weight of pineapples. Grown in the field. Grown in the field. All right. So, it's been known before that the mean was 31. But you think that you're changing something and it'll change it. You didn't say it's going to be less than or greater than. You said you think it's going to be different. So this is a two-tailed test. Now there's something to do with this unless you're just using calculator. If you're just using calculator, it makes your life a lot easier. So we stated, we're going to plan. Is it simple random sample? Yes. Is it normal? N is greater than or equal to 30, so yes, central limit theorem. And 10% independent. Yeah, there's more than 50 pineapples, y'all. Do. I'll be back with the do. I'm back with the do. I did the do. I got T was. All right. This one we're looking at the milliliters per or milligrams per liter aquatic life. I'm gonna hit stat, edit, and plug in my data. All right. I'm gonna hit stat, test. Now this is a one sample, right? We took one sample. T test. All right. All right, I guess I can just go t-test. Sorry, guys. Let's try it. So what's our null hypothesis? Our null hypothesis is we think that it's 5, right? We're using list 1, frequency 1. And we believe that our null hypothesis is what? It's too big, right? So we think that the real mu is less than our null hypothesis. Hit calculate. Boom. Got it. Data. Done. I got my t-value. T is negative 0.943, and my p-value is 0.181 or 809. All right, our degrees of freedom was, look at this, well, 14 because it's n minus 1. All right, sorry that one wasn't great. .76, p was 0.008, right? So, conclude, listen to this. All right, so our p-value is less than our alpha, right? Because our p-value is less than our alpha, that means we can reject the null. And if we reject the null, we have significance evidence. So my final conclusion statement would be, we have convincing evidence that the mean weight of pineapples in this year's crop is not 31 ounces. So it means the irrigation system had an effect. Guys, I hope this was helpful. Ask questions where needed. Enjoy.